Emissions have increased every year since I've been born.
If we do nothing, the consequence is warming of the earth, deoxygenation of the ocean, extinction of all higher life forms.
We need to stop putting CO2 in the atmosphere. It's that simple. That's what causes climate change, and that's what's driving our civilization to potentially go over the edge.
We know that we put too much carbon dioxide into the atmosphere, and we know that we have the technology and the engineering to clean up that carbon dioxide emission, to put that carbon dioxide back underground.
The suite of climate models that show how we can achieve the mitigation of dangerous climate change, they are underpinned by the requirement of vast quantities of carbon capture and storage.
The ALIGN project has been designed to support the delivery of carbon capture and storage, or CCS, in 6 of Europe's industrialised regions. The combined results will be used to create blueprints for developing low-emission industry clusters through CO2 geological storage. A major goal of the project was to assess public opinion on industrial CCS. Research in ALIGN shows that one of the main reasons the public supports industrial CCS is because of its contribution to reducing CO2 emissions, thereby helping to respond to the climate crisis.
Carbon capture and storage is a technology that is preventing carbon dioxide from going into the atmosphere. You're capturing it, you're transporting it, usually through pipelines or sometimes from ships, and you're storing it deep underground in rocks. In Europe and in the UK, we usually are talking about deep underground, underneath the sea, so that the carbon dioxide can't get back out to the atmosphere. It's safe and secure in those rock cores.
Where you had a process of extracting carbon from the North Sea and bringing it onshore, we can now use that infrastructure but for the process in reverse. We can take the carbon from the shore and bring it back out and sequester it permanently.
The project that I work on, the ACORN project, we are looking at capturing carbon dioxide from the St Fergus gas terminal, which is right up in the northeast coast of Scotland, transporting it offshore using gas pipelines that are no longer used for bringing natural gas onshore, and then storing it in rocks deep underneath the North Sea.
We can flip it on its head. So something that was designed to provide wealth but also to provide CO2 to the atmosphere can be put in reverse and take CO2 out of the atmosphere or prevent it from leaking from industry in the first place. It's not universally like that all over Europe, but in certain places there is certain infrastructure that we can reuse very soon, right now, to prevent climate change or further climate change.
We know the technology, we know how to build that, and we know where to build that, and we know where we can put that carbon dioxide, where it will be safe and secure, put back underground for millions of years into the future. And that's a way of safeguarding the atmosphere so we can still retain the benefits of using that fossil carbon and giving us those energy benefits and those lifestyle benefits and those plastics and paints and clothes and growing food with fertilizer derived from organic oil products, but without the penalties and the disbenefits of causing climate change.
The Norwegian state enterprise for carbon capture and storage, Gassnova, has been operating successfully since 2005 and since 2014 has been working on what may become the first industrial-sized project for carbon capture and storage in Europe.
What we're hoping for, if we get the investment decision and we start developing this, we think of it as an infrastructure in the North Sea. So we have surplus capacity in our transportation and storage part of the value chain. And we're offering other industries, other countries to send their captured CO2 to the North Sea and to the geologic store that we are planning to establish. And we hope that this will be an inspiration and make the effort a bit smaller for other countries and other industries to follow.
We've seen the UK government make statements about the fact that CCS is a necessity in reaching its net zero targets. And we've also seen some really exciting funding announcements. So we've now got 6 industrial hubs and clusters being explored, where you've got concentrated industries that are CO2 emitting, all in one area where the CO2 will be captured from this industrial hub or cluster, and the CO2 will be taken to the storage site.
Teesside is the UK's most integrated industrial cluster. It is Europe's second largest, most integrated industrial cluster, which means that it's a really compact location with some significant world-leading energy-intensive industries located there. And those industries produce the products that we use every day. And it has a really big contribution to the UK economy. It exports more than it imports. GVA is 3 times the national average. Wages are twice the national average in the chemical sector. It's a really important sector for the UK economy. And so to decarbonise these industrial clusters, CCS is absolutely vital because there are very few other ways you can decarbonise most of these processes.
Carbon capture and storage is a technology that's attached to industry. It's not something that people are going to be very aware of. They're not going to see it every day in their lives.
We're not going to take it past people's houses. We're not going to be digging up fields. We're not going to take pipes huge distances. This is something which is going to be integrated within an already industrial landscape. And it builds upon the infrastructure which is already there. So if you look at Teesside, we already have pipe corridors connecting lots of the different industrial plants. Industry is already used to working with each other. They're already used to that level of integration that would come with an industrial CCS network.
The other thing that's been incredibly positive about these industrial hubs and clusters is the fact that they are working together. That it's a competition, but it's a competition in which it's understood that whichever one wins or goes forward, they will be leading the way, but they will also be sharing knowledge with the other hubs and clusters, which will then come on board as time progresses.
The beneficiaries of that are all of us, because that enables us to use the oil and the gas to make the chemicals and the products we have at this oil refinery and this petrochemical plant, to keep the literally thousands of high-value jobs employing those people here and in and around that industrial cluster complex, and to gain the benefits of that for the citizens around here, and the benefits of that for all of the people who those products go out to in the UK and in Europe and in many cases worldwide. If we fail to capture that and be courageous and invest in carbon capture and storage and let this chance pass by, then we can make all these somewhere else in the world. And we won't have any jobs here, we won't have the skills, we won't have the benefits, but the high carbon manufacturing will be somewhere else in the world, emitting even more carbon than we would have done here. And we'll still be buying those products, but the world will be a worse place for it.
The employment opportunities arising from implementing CCS in industry have been shown by ALIGN research to be an important reason for its positive reception by the public.
In terms of talking with local communities, the way that CCS has been framed has often been around the need to have climate action. However, there's been a growing understanding that actually what people care about as well as climate action is also about jobs, about financial security, about the longevity of their livelihoods and of those around them. And so we're starting to realise that there's a really important messaging element here, that CCS is not only critical in delivering climate action, but it also presents a suite of employment opportunities. So I think reframing carbon capture and storage as a necessary climate action pathway, as well as a means of ensuring this just transition. So how do we keep employment and prosperity whilst also delivering net zero? And CCS has got a really important role to play there.
There's a lot of people who work in oil and gas, not just on the rigs, but in all the other things in the offices and different bits of the supply chain. And all of these jobs are heavily dependent on oil and gas activity, which you could quite strongly argue that is not compatible with the obligations that we have to respond to climate change. And so what we started to think about through various research projects was what the role might be of CCS within a just transition. Because on the face of it, it makes a lot of sense. We've got oil and gas fields that are potentially suitable, that we know very well. We know the characteristics of these fields well. We've got some of the infrastructure, and also we've got a highly skilled and very capable workforce. It's important to remember that a lot of the people who work in oil and gas are not just oil and gas workers, they're engineers. They've got particular ways of thinking about doing things, about solving problems, about putting solutions in place. And there's a lot of really useful and valuable skills there that will help us to do the move to a zero carbon society. And so we started to think, well, is there any way that carbon capture and storage could be something that helps us do this just transition for places like the northeast of Scotland that are quite heavily reliant on oil and gas.
The findings from ALIGN show that the public continues to be mostly concerned about the risks of CO2 leakage from pipelines and from the rocks deep beneath the seabed, where the CO2 will be stored.
The sites that we're looking to store CO2 have been selected so that there are minimal or no leakage pathways to surface. When we put CO2 into the rock formations underground, we'll be also monitoring these sites quite rigorously, looking at where the CO2 is moving, where the CO2 is migrating, is it migrating as planned, and then also looking at this surface, whether it's the seabed or the land surface, is there any indication of any leakage to surface through some pathway.
So this is one of the core things that returns to CCS all the time. What's not to say that the CO2 won't come out a day later or 100 years later. And this means we need to monitor it. So there's lots of different technologies for that, so I won't go into that, but having that written in law and in legislation in Europe to say that CO2 can only be regarded as stored if it's done to this very high standard, that's what we try to do as an NGO. We try to make sure that that monitoring and verification and that guarantee that CO2 will be stored permanently is in law.
ALIGN research has shown that in other countries, trust in the government and industries is not necessarily high. It needs to be earned and maintained by good communication and engagement with the general and local publics.
People are familiar with the oil and gas business that's been around for 50 years. So they trust the industry and what they do and the knowledge they have. And so this is a good basis for talking about CCS in Norway, because they know that it's been going on for 24 years. It's been safe, no leakages, everything has worked in a good way. And then, of course, when you start to do capture of CO2 onshore, then you get more attention from stakeholders. And of course, there we have tried to communicate to the public. And also, I think the increased interest we see on climate issues in the public in general has led the way so that we can talk more about the importance for CCS. And already people would trust the industry that this is done in a good way.
Another major goal of the project was to improve dialogue around CCS.
In Europe, we've got countries that have got really very, very different perceptions about energy and where we get our energy from and the importance of tackling climate change. And for people who are trying to get those messages right, survey work like has been done in the ALIGN project is really quite important for that baseline information to allow people like me to come in and do the communication work around carbon capture and storage and what difference it can make to industry, but also to our collective attempts to tackle climate change as well.
It's really important that we work with the general public and local communities who live nearby CCS developments to ensure that the development is delivered in line with their desires for their local area, that's in line with the wants and their needs around assurance of monitoring and so on. But the first step before you can really understand people's views about CCS is to enhance knowledge.
Also wider than just the communities that are impacted, that we actually, I think, improve people's understanding of how we are looking to tackle climate change more generally, that there's not just one solution to this. It's not about using just renewables or electrification. It's about all the different tools that we have to tackle the climate emergency and how we can use them all. And carbon capture and storage and hydrogen are two important tools in that tool bag.
A further goal of the ALIGN project was to work out how all this is paid for.
The question has always been who pays for all of this, and that's one of the main barriers also to pushing this forward.
What we have decided to do with the demonstration project we're now setting up is that we treat the emitters in one way, so they can deal with their own emissions and find out how to capture their CO2. And then we're investing in an infrastructure for transportation and geologic storage, so that it's clear what the responsibility is for instance, a cement producer. They don't have to worry about what happens with the CO2 once it is being captured. But on the investment side and the support from the government is quite similar in those different parts of the value chain.
I see two short-term incentives. One is a price on CO2, emissions, the polluter pays principle, and that's, you might say, a stick, and then we also have carrots to start with, which is subsidies. And so that is a huge incentive to get started. I don't see that as a sustainable manner for paying for CCS implementation. So over time, we will have to move into a CO2 pricing scheme. And in the end, I do foresee that the customer pays for this through the price that he or she pays for the product.
CO2 capture, transport and storage is an added cost to existing industry. But it means that instead of making cement that dumps its CO2 in the atmosphere, you can make cement that has zero emissions. The same for steel, the same for some chemicals. So it all depends on what society is willing to pay. So how much would it mean if, let's say, we're building a house? What cost increase would we have if we were going to use clean cement made with CCS, than cement otherwise? And generally looks to be about 1.5% to 3% cost increase, which I think society can afford. If we want to build clean houses and clean infrastructure, we can afford to do it. We don't choose to at the moment. We say things are expensive. We say we'll wait a while. We say we'll wait for another solution in the future. But time is running out. At the moment, we're just talking we need negative emissions to begin to rewind the CO2 we've already dumped in the atmosphere. So time is gone. We just need to make a decision that we want society to continue, and we need to start paying that little bit extra to have clean products in our society.
We have worked on this particular project for 5 years now, and we're ready for the investment decision. If we get that decision and the funding is there, we will start developing the project 1st of January 2021, and it will be ready for operation in the fall of 2024. So in the next 5 years, we hope will be in operation, and the infrastructure will be in place for others to join. And I think the minute we make that decision, I think that could change the speed things are happening in other countries around the North Sea basin.
All the simulations that have been done say, yes, we can reduce our carbon emissions by being efficient, we can reduce our carbon emissions by building renewable energy, but those are not enough.
We need everything on the desk right now. We need wind turbines, we need solar power, we need electric vehicles, but for the really hard to abate areas, when we're talking about cement and steel and chemicals, you're going to need an end-of-pipe solution. You're going to need a CO2 transport and storage network.
There's no other technology or industry which is big enough, which can be developed fast enough, which can be pervasive around the world to enable people to do that.
To me, it's not about whether this is possible, because it has to be possible. If we are going to have action on climate change, deep emission cuts, we need to deliver CCS.
CCS is something we can do right now. So we only do CCS if we're really serious about tackling climate change and really serious about not emitting more CO2 into the atmosphere. So I think we need to turn from hyperbole and narratives about what we could do about climate change to actually wanting to do something about climate change. And then CCS becomes really real really quickly.